Welcome to the Lighting Controls Association's online education course, Luminaire-Level Lighting Controls. I'm Craig DeLuey, Education Director for the LCA. Luminaire-level lighting controls are a lighting control option in which sensors and control functions are embedded in luminaires to enable individual luminaire control. By integrating control functionality into each luminaire, control is highly flexible, responsive, and therefore generally highly energy saving. Additionally, significantly detailed space use data can be generated as a potential feature of centralized systems. This course is registered with the American Institute of Architects. Course credit is recognized by the NCQLP and the state of California. Education Express is recognized by the Design Lights Consortium as furthering controls education, and it is a foundational course for NALMCO's CLCP certification exam. Needless to say, this does not imply endorsement by these organizations. Check out the course at LCA's Education Express to learn more about how to get course credit, the copyright, and our standard disclaimer about this information. Now let's get started. By the end of this course, you will be able to explain luminaire level lighting control to clients, identify its benefits, match it to the right applications, and design lighting solutions that recognize the basics of what is required to use luminaire level lighting control. To that end, we will define and categorize luminaire level lighting control and describe its characteristics. From there, we can evaluate its advantages and disadvantages and how it fits into energy codes, rebates, and applications. Armed with this knowledge, we can then talk about designing and installing luminaire level lighting control systems. Various organizations have defined luminaire level lighting control in similar ways. The core definition is a luminaire with embedded sensors and control functionality. This may be accomplished via an LED luminaire or luminaire retrofit kit. The controls package may come pre-installed with assurance of compatibility or as discrete components that can be installed in the field. The luminaires may operate standalone or be tied together on a network as either a room-based solution configurable with software such as an app, or a centralized building-based solution capable of programming and generating occupancy and other data. Note that manufacturers take a variety of approaches with these concepts, such as wired instead of wireless connectivity, or placing the lighting controller or intelligence outside the luminaire. In the majority of luminaire level lighting control systems, the three major control elements installed in the luminaire or retrofit kit are sensors, control functionality, and wireless or wired connectivity. The control functionality may be an integral part of the LED driver or drivers, or a separate device that sends dimming signals to the driver. Wireless connectivity is achieved via an onboard radio transmitter and receiver connecting the luminaire to a network with various standard and proprietary protocols available for this job. If these elements are from a single manufacturer and installed in the luminaire to factory, compatibility is assured, controls installation is simplified, and the luminaire arrives programmable or with a pre-programmed sequence of operation. The basic luminaire level lighting control layer places key elements of an autonomous yet groupable control system within each luminaire with a versatile range of inputs and outputs. Inputs include the occupancy sensor, light sensor, manual controls, and any programming. The control functionality decides whether and how to change the lighting based on the configured sequence of operations. Depending on the specific system, variables can include scheduling, switching, dimming, color tuning, and data. These combinations of inputs and outputs enact a range of popular control strategies, including occupancy sensing, daylight responsive control, scheduling, high-end trim, manual override, and more. Depending on the system, centralized network hardware and software may be layered on top of the basic solution. The hardware may include hubs or gateways and a central server. These hubs and gateways serve as central collection points for managing the flow of data in the network. Software is then used to display the data and access the system. Luminaires can be grouped, assigned to one or more control zones and strategies, and given a sequence of operations, any of which can be changed at any time. The Northwest Energy Efficiency Alliance provides helpful categorizations within the general category of Luminaire-level lighting controls. They identified clever Luminaire-level lighting controls as systems that satisfy the basic DLC and IECC requirements. One might think of this as a basic layer, LLLC. Its primary value proposition is simplicity in installation, flexibility in application, and in maximizing energy savings. Smart systems add a global networking layer for additional capability, tying the luminaires together in a centralized control scheme. This allows programmability, integration with other building systems and sensors, and the generation of data. The primary value proposition of this approach is the ability to globally fine-tune performance and realize non-energy benefits, such as optimizing space utilization. The third category NEEA discovered was clever/smart, or hybrid. This is essentially a clever solution, but with select advanced capabilities. For more advanced systems with centralized control connectivity, additional control strategies are available via integration with other building systems. Additional control strategies such as HVAC room temperature, shading, and plug load control can be incorporated. The luminaires can also integrate other sensors such as air temperature and humidity sensors and low-resolution infrared cameras. Fine-grained occupancy and other data from highly distributed sensors can be captured for purposes such as space optimization using the manufacturer's software. Sensor data may also be fed to third-party, in some cases custom apps. If paired with Bluetooth or Wi-Fi connections, operators may gain the additional ability to enact asset tracking. Overall, by embedding sensors and control functionality into each luminaire, control is highly granular and responsive, which can result in improved energy savings. For the electrical contractor, luminaire-level lighting controls can ensure control compatibility, simplify wiring, and reduce time and risk by eliminating installation of control devices. Functional testing typically becomes the responsibility of the contractor as opposed to an additional party. For the electrical distributor, it offers an energy-saving solution that can streamline product schedules for lighting projects. The designer gains flexibility by reducing the need to predetermine switch leg wiring and zones. The owner gains energy savings, the ability to fine-tune and reconfigure the system in the future, and potentially advance functionality and data. And users interact with a lighting system that satisfies energy codes while offering personalization potential. As with any lighting system, there are disadvantages. The primary inhibitors are the luminaire's higher base cost, higher complexity of the project, insufficient value or savings for a given project, and uncertain owner interest in advanced functionality. In addition, occupants and designers may have objections to systems that permit every luminaire to operate independently as opposed to in a uniform and coordinated manner. For many situations, the advantages will outweigh these disadvantages. Initial costs can be offset through simplified hardware installation and value-added functionality. Additionally, careful system selection can anticipate other concerns and result in a solution that is well tailored to the needs. The 2018 and 2021 versions of the International Energy Conservation Code specifically mention luminaire-level lighting controls in section C405.2. This section identifies two paths for compliance with the code's automatic shutoff, light reduction control, and daylight response requirements, one based on standard control devices and the other on luminaire-level lighting controls. In open offices, where the IECC requires occupancy sensing with control zoning limited to a maximum of 600 square feet, luminaire-level lighting controls can simplify installation. While not mentioning Luminaire-level lighting controls directly, the 2022 version of ANSI ASHRAE IES 90.1 and the 2022 version of California Title 24 Part 6 contain similar requirements for limiting the zone size of occupancy sensing in open offices, which provides opportunities for Luminaire-level lighting controls. A majority of commercial lighting rebate programs incentivize installation of energy-saving lighting controls. Standard rebates incentivize devices such as Luminaire integrated occupancy sensors and daylight dimming systems, for which Luminaire-level lighting control systems will often qualify. In addition, rebate programs that incentivize and advance lighting controls may align with Luminaire-level lighting controls to allow access to these more comprehensive opportunities. According to rebate fulfillment firm BrightSwitch, more than 1/4 of rebate programs now separately incentivize installation of network lighting controls, or NLCs. A majority of these programs qualify products based on listing in the DLC's NLC qualified products list, which in 2022 transitioned to version 5 technical requirements. These technical requirements combine required and reported system capabilities, of which Luminaire-level lighting control is a reported capability. Generally, two types of applications are most suitable for Luminaire-level lighting control strategies. The first is situations where both Luminaire-specific granular control of luminaires and coordinated zonal control are beneficial. Examples include open office coordination of occupancy zones, space requirements, and daylighting zones. The other situation is the use of the granular data from certain smart Luminaire-level lighting control systems to contribute to space optimization and facilities management. For example, occupancy sensors on every luminaire combined with detailed building drawings could be extrapolated into occupant traffic patterns. In August 2020, the Northwest Energy Efficiency Alliance published a study seeking to compare one-for-one Luminaire-level lighting control retrofits with a comprehensive network lighting controls redesign. This study found that a one-for-one Luminaire-level lighting control upgrade produced comparable energy savings and lighting quality as an NLC redesign at a competitive cost. Based on the monitoring, the 5 Luminaire-level lighting control options generated 50 to 74% energy savings for the controls alone, while the NLC solution demonstrated 67% energy savings. The highest performing Luminaire-level lighting controls had additional features such as scheduling, task tuning, plug load control, and energy monitoring. In this space, the installed cost for the Luminaire-level lighting controls was roughly 1/3 to 1/2 of the NLC redesign option. The NLC performed best for savings due to high-end trim, but lowest for occupancy and daylight sensing, which is due to fewer sensors and less granularity in the control response. In January 2021, the Northwest Energy Efficiency Alliance published the 2020 Luminaire-level lighting controls incremental cost study. This study was designed to estimate the average incremental installed cost, product plus labor, of Luminaire-level lighting controls to the end user compared to LED luminaires with no controls. As a secondary goal, the Northwest Energy Efficiency Alliance also compared the incremental cost of Luminaire-level lighting controls to luminaires plus controls installed to achieve minimum energy code compliance. The Alliance estimated a total average incremental cost for each of the 3 major types of Luminaire-level lighting control systems. Based on a 40,000 square foot prototypical office building, the average incremental cost breaks down to 58 cents per square foot for Clever systems, $1.16 per square foot for Smart systems, and 78 cents per square foot for Clever Smart hybrid systems. In new construction, the incremental cost of making the lighting system, quote, Internet of Things ready, with a smart LLLC for a prototypical office building is an average 15% higher than a lighting system that satisfies code minimums and 7% higher than a basic Luminaire-level lighting control system that maximizes energy savings. As a lighting solution of luminaires, a luminaire-level lighting control system is designed similarly to a standard system. Overall, the lighting must satisfy the owner requirements and basis of design. Attention to detail, however, must be given to aligning task areas and dedicated luminaires. In an open office, for example, a typical luminaire serves 80 to 120 square feet, while the control zone for an onboard occupancy sensor can be limited to a roughly 8 by 8 area, suitable for 10 by 10 workstations. As a control solution, a luminaire-level lighting control system can simplify energy code compliance, particularly in complex spaces such as open offices. If that is the sole goal, a clever luminaire-level lighting control system may be appropriate and achieved with relative ease. With smart systems, the luminaire-level lighting control may be programmable from a central point with data collection. Design flexibility is gained in current and future control zoning. The designer can spend their time on optimizing energy savings, performance, and resulting design value rather than checking boxes for code compliance. The designer should familiarize themselves with integration and data capabilities for various systems. The designer should also note the installation of a network may require owner IT buy-in and involvement. Depending on the product capabilities and specific configuration ordered, some luminaire-level lighting control systems can be configured for different control objectives. For example, the designer could zone the direct or task component of direct-indirect luminaires to be individually controlled, but the indirect or ambient component to be controlled as a group. Or a row of luminaires might operate independently for occupancy sensing, but be assigned to a group for daylight response. As with any control system, the designer should produce a clear written controls narrative or sequence of operations, which defines what each control point does in response to what inputs. If required by a smart luminaire-level lighting control system, the designer may need to incorporate the networking hardware, hub, gateway, server, and software into the project deliverables. Some applications can be served by wireless networking, wired networking, or a hybrid wired-wireless solution. The designer must also decide how programming and data will be accessed, web browser, mobile app, and who will be allowed to access it. Ideally, automatic control effects implemented by luminaire-level lighting control luminaires should be free from distraction to any users in the area. The most tangible interaction with the control system occurs at the manual control interface, the wall station, which may be wired or wireless. The wall station may provide users with a variety of interactions, such as the ability to override the system to off, choose the light level, select preset lighting scenes, or a combination of these functions. To encourage user satisfaction, the interface with the wall station should be intuitive and simple to operate, with consistent, easily understandable labeling. Luminaire-level lighting control systems have unique opportunities related to installation options. In particular, when luminaires with pre-installed wireless luminaire-level lighting controls are deployed on a project, installation can be greatly simplified. Additionally, sensors, controllers, and drivers are pre-tested as compatible. Depending on the type of luminaire-level lighting controls and the needs of the project, there can be fewer requirements to mount discrete sensors, or perhaps no need for discrete sensors at all. And for smart systems, the amount of supporting hardware is likely reduced. Clever luminaire-level lighting control systems provide further potential benefit during installation because of the lack of supporting hardware in many cases except for switches. If it is a wireless solution, no control wiring is required. This can be particularly advantageous in a lighting upgrade project in an existing building, where utility rebates may be available to reduce cost. Despite potentially simpler installation of an integrated lighting and control system, labor should be expected for configuring the sensors, manual controls, network and communications between the devices, and additional components such as gateways and central controllers that may be needed. Contractors interested in luminaire-level lighting controls should familiarize themselves with the technology, particularly the principles of wireless communication, and specific products, which can vary in approach and setup and programming. Configuration of Luminaire-level lighting control systems is often through software accessible via a mobile app or web browser if a centralized system. For centralized systems, the software is more sophisticated and enables facility operators to organize and program the network and also view the data in a useful presentation format. Luminaire-level lighting control offers distinct capabilities, excellent flexibility, installation simplicity, good energy savings potential, simplified energy code compliance, access to rebates, and other benefits. It starts with embedded controls but can extend to network solutions for additional capabilities. Luminaire-level lighting controls is highly suited for offices, schools, and a range of other applications. These luminaires are designed and installed similarly to non-luminaire level lighting control luminaires, but with special attention to aligning luminaires in task areas, as well as configuration of any special hardware that may be needed. As with any lighting control solution, a clear written narrative is recommended. And also as with any lighting control project, manufacturers stand ready to help. This course is accredited by or registered with industry organizations. This course is registered with the American Institute of Architects. Education Express is recognized by the NCQLP, the DLC, and the state of California. And it is a foundational course for NALMCO CLCP certification exam. You can learn more about this at our website, lightingcontrolsassociation.org. To earn education credit for this course, click the link in the video description to take a quiz. A passing grade of 80% for AIA and 70% for all other recognizing organizations qualifies you for education certificates. Registration with Education Express is required. And now a brief word about the creators of this course, the Lighting Controls Association. We are the voice of the lighting controls industry, a council of the National Electrical Manufacturers Association formed to educate the public about lighting control technology and application. Our hallmark program is Education Express, a series of web-based courses on a wide range of topics. At our website, you can find this and plenty more, including articles, new product introductions, award-winning projects featuring controls, and more, all at lightingcontrolsassociation.org. And that concludes our course. Thank you again for attending. We hope you found the information useful for your business, and we wish you success in developing your next project using Luminaire-level lighting controls.